not knowing where they're going. Alrighty, friends, so Friday, we don't normally have class on Friday, but you don't have any classes on Friday. Just please remember that. I like to spread that good news for all of us. I have a really quick question. I wanted to get your feedback in particular, this group of folks. I want to do a math on the quad day. So like get chalk and have a bunch of people do it. I'm trying to figure out the best time and day, and I was kind of thinking like a Friday. Is a Friday afternoon like good?
The campus is kind of quiet.
Yeah, campus. Most commuters don't have classes
Class on Fridays. Yeah.
Okay.
Yeah.
So when do you think is like it's tough? Like a Wednesday?
If you want to have a lot of like foot traffic.
Yeah.
Like what time?
During lunch or something.
Ooh,
Between
lunch, yeah.
lunch and
Noonish.
dinner. Yeah,
Yeah.
the commuters are usually on campus for lunch, and then after like usually these classes end, or like 4:45 classes end, they go home.
Okay, so like a 11 to 1. Would a
Yeah.
Tuesday or Thursday be okay or not as good?
I could go.
Because I
like an
teach
hour
like
then.
till 12:15 and I'd have to cancel calc.
Nah.
And I don't think I should do that. I've already done that enough.
I
So,
think Thursday could also work.
a Thursday could
My
work?
Schedule, yeah.
Okay. Like same time frame, that kind of lunch, like,
I could.
Honestly,
Yeah.
right after this class, like next week,
oh,
Maybe.
like that late in the afternoon, like at 3, maybe? I don't know, who would come and just, all you'd have to do, I got all the chalk, who would just come write some math on the sidewalk in front of the, yeah, would you actually come? Like a lot of times people say, oh, I'm totally gonna be there, and I'll be out there like crickets, like listening to nothing. But you would?
Yeah.
Yeah?
Yeah.
Okay, cool. And after this class, maybe, or is that, you think that's not good? That's the vibe
I
I'm
work
getting.
at like 4, so it's
right.
fine. It's a marathon.
Got it. Okay, I'll figure it out, because you're my main core of people who respond to this. So, yeah, we'll figure it out, but it's gonna be in the next 2 weeks. I got permission from Dave to draw it there. And, what's that? The week before. Yeah, that might be good, right? That last week of classes, just come out there and like draw. Just do math. Yeah, you could do whatever
it's
math
like
you
office
wanted.
hours, but like
Outside.
It just has to be potentially related to math. So, and that would be very much. Sweet, okay. Beauty. Let us solve a differential equation together with Laplace transforms. Let's see, what did I got set up here? Okay, y0 is 1, awesome. I just want you to appreciate like how this is gonna be fun. This is where Laplace transform starts getting awesome. Because once you're good at it and you can see these things, and you will after just doing enough, solving this is so quick. Let's just think, right, what should we expect before we go? Let's just think about it with the knowledge we have. What are the roots gonna be on the left? 3. Lambda minus 3. It's the characteristic polynomial. So if I get a 3, what's the root on the right? 3. So I expect a repeated root kind of thing, you know, with t e to the 3t in it. Just thinking about what should this be? But we're not going to actually solve it that way. We're going to set up for Laplace transforms. So the first thing you want to do is get some nice notation. And you want to let some variable, if this was little x, I would make this big X. Did I actually start? Kyle, could you please just check and see if if I'm rolling back there, sir?
I've been fired.
Yeah, you're good.
Thank you. I just thought you were too good for it. That's why you moved away. So, set this up so you don't have to write this collection of symbols over and over again. Whatever you want, however you want to do that. Then apply the Laplace transform to each side. Let's remember a couple of things. The Laplace transform of y prime is going to be s times the Laplace transform of y minus y at 0. Well, that's all we need for right now, so that's pretty good to stop there. So this, when I take the transform of that, it's going to turn into S Laplace transform of y minus whatever the initial condition is at 0. Minus 3 times the Laplace transform of y. There I'm using linearity in that the Laplace transform of negative 3y is equal to negative 3 Laplace transform of y. So I'm just pulling that scalar out in front, just let it ride, and then I'm done with the left side. So now on the right side, we're going to get the Laplace transform of e to the 3t. Laplace transform. You've got a little sheet in front of you, and then these will all become very easy at some point. But that's the formula. So this becomes 1 over s minus 3. So that's step 1. Step 1 is take the Laplace transform of each side. Step 2 is use algebra to isolate the Laplace transform of your solution. Not too bad here. And you might want to sub in for whatever initial conditions are. We know that that's 1. So just making a little note that that is just a 1 there. First thing I would do is actually add that to the other side. So let's do this step by step so you have nice notes on it. I'm going to have sy minus 3y equals 1 over s minus 3 plus 1. That's that y at 0 just came across. Factor whatever comes out of here times y in order to isolate that y. You should get the characteristic polynomial here. This will literally be the characteristic polynomial if you were doing this old school, right here. Divide through by that. Step 3, take the inverse transform. And so on the left side, I'm going to get y of t. And on the right side, I'm going to get, let's just write it out so we have that here. Some of that's pretty easy. This one we should know because we literally already did it, right? What is that? What does that come back to? 1 over s minus 3. E to the 3t. Right? Look backwards, just look at them backwards. So it's just e to the 3t. This one we might need a little bit of work on. So let's think about how that shifting works. So I've got Laplace transform, inverse transform of something is equal to e to the negative kt L inverse of f of s minus k. So in other words, replacing s with s minus k. Let's write that out with the kind of the English language way to make it feel good. So it's L inverse of f of s with s replaced by s minus k. If you don't like this formula, see this version here, sometimes that minus messes people up. I just want to give you an alternative, or you could write it like this, just e to the kt, L inverse of f of s plus k. Replacing s with s plus k. Which kind of helps in a way. Sometimes I think this one's a little, I don't know. You don't have the double minus and all that shit to worry about. What do I need to replace? Let's break this down. Sorry. Let's get everything out first. There's actually a couple of ways to do this. We'll do both of them. So this one we got. This is the one we need to figure out. We don't know that transform, but we do know L inverse of 1 over s squared. What is that? What's L inverse of 1 over S? Yes, 1. Indeed. 1. Use your sheet. What's on that sheet? How do you get just S's in the bottom? It's T. Absolutely. This is T. So what we're using here is this formula backwards. L of T to the n is n factorial over S to the n plus 1. So when you see anything over S to a power just by itself, it's a power of T. It might need some tweaking, but you're good to go. So I can write this backwards, and let me do that. I'm going to write this backwards a couple ways. Might want to even make these little notes on that sheet that is T to the n. So we could write this as L inverse of 1 over S to the n plus 1. So I just got that. I don't have a number on top. Is 1 over n factorial T to the n. That's not a bad formula to have around. It's going to happen a lot. Notice what I did here. I just multiplied both sides by 1 over n factorial to get that 1 there. Use linearity to bring it inside and cancel. Good stuff. So that's just T. That looks a lot like this, except we have S replaced with S minus 3. So I want to undo this. Let's actually do a little scratch work over here. So L inverse of 1 over S minus 3 squared. Well, I'm going to replace S with S plus 3. And that's going to turn this into 1 over S squared. See if you see that what I'm doing is subtle. I'm using our shifting property that's right down there. If I replace this S with S plus 3, then I get S plus 3 minus 3. Hard to tell what you guys feel about that, but we'll keep going. So this is equal to e to the 3t, L inverse of 1 over S squared, plus, we'll just do this one, that's just e to the 3t. This is t, so this is t e to the 3t plus e to the 3t. I'm done. That's my solution. And it took long because I'm doing all this little reminding us of things, but otherwise we could have just done it in a minute or so. If you got this in your head and locked up. Is there any questions about that? And you really got to do this yourself, right? Like all math, it's easy. It looks so easy to watch. It's when you're in there in the trenches dealing with it that it becomes rough. I got one more I want to do, but I want to make sure everybody's got this down and got no questions. Yes?
I'm kind of confused on the property that we pulled into the case for that one.
This property here.
Yeah.
So can you give me more help with what's confusing you?
I don't know.
Like how I did this?
Yeah.
Okay, so I don't recognize that S minus 3 squared. It doesn't look like any formulas we've come up with. So I'm going to turn it into this. To turn it into this, I would have to replace S with S plus 3. Notice that if I do that, Olivia, that if I replace S with S plus 3, then I get that, which turns into that. So I'm looking at what I've got, where I want to go, and then doing that. So if I replace S with S plus 3, that turns into this, but I have to pay for that somehow. So the e to the 3t comes out front to say, oh, you replaced S with S plus 3 to get this. Does that help a little?
Yeah. I think so.
And like I said, seriously, you just got to do this a few times to make it really stick. Other questions? Oh, got one more to do before we cut loose here. This one we're gonna have y double prime minus y prime minus 6y equals t. We are gonna need a tool for this one in a bit. And it's that tool I mentioned, the partial fractions calculator, that's up on World Class. I should probably start waking up the squirrels that power this machine. Squirrels, I've got nuts for you. Let's see. All right. Just start getting that in there. Oh, sure. Bastard. All right. That's right. Okay, cool. So let's take the transform. I'm going to let you do more of this one than I did on the first one, but I'm going to give you help. We'll keep that up. Let's do this. L of y double prime is going to equal s squared, Laplace transform of y, minus s y at 0 minus y prime at 0. Little tip for remembering this. Notice how this one is just that one times s minus the next level of derivative initial condition. So it's just s times this minus y prime at 0. That's how I remember it. So could you do me a favor and just take the Laplace transform of each side of this, please? Let's talk in a minute. Start getting up this calculator. Oh, how about some initial conditions? That sounds good. Let's see, that was y at 0 is 1, y prime at 0 is 0. That makes life a little better. Everybody got that video I sent out, hopefully posted? Yeah, please, I recommend everyone please take the time to watch that through, especially if you haven't started that assignment yet or you're having trouble with it. Even if you did, because Vivian, I was actually worried about like some computations you were asking me about. I don't know if you had a chance to look at it, but does it match what you were doing? Because I was thinking about what you were doing, I was like, wait, was that right? I wasn't sure, so. You were asking me about like your Laplace, or you were asking me about some kind, oh sorry, on the mass spring problem 2, that whole big nasty one. You'd show me some computations on it and said, is this like going in the right direction?
It was the first problem.
Oh, was it? Oh, okay, cool.
Actually, yeah, I did show you.
I thought so, because there was a lot of variables floating around. Yeah.
I did show you.
So check out what I did to make sure that, okay. Just looking. This can be factored. Do you see the factorization? You don't necessarily have to factor that, I think, with these calculators, but do we see the factorization here? S minus 3, S plus 2. I'm going to stop and make sure everybody's with me and that everything is making sense so far. Or should we talk? It's like, we're almost there, right? Feels like it. It's gonna, there's like something over the hill we haven't quite seen yet.
Why is it a -6 and not a +6?
This here?
Yeah, the one below. Why is it S squared minus S minus 6?
So, okay, do you agree with all this? Yeah. So this is a -6y. And so when I was looking at just the y stuff, Daniel, it was just those three terms.
Okay, I see.
You got it? Okay, cool. Yeah, there's a lot of stuff going on, so it's pretty easy to.
Where did you get the first just minus S?
Oh, this. So this, I used the formula for the second derivative transform. And that's s times y at 0, and y at 0 is 1.
Oh.
So then I plug this in. Does that make sense? Yeah? Awesome. Good stuff. Good talk. Divide through by s minus 3, s plus 2. And I'm going to actually put those on top of just this product here. Nothing wrong with that. If I wanted, I could even combine these into one fraction before I did the partial fractions. I'm not going to, because we've got a calculator to make life easy for us. Let's talk really quick. I'm not going to ask you to do this for a while, and probably not ever for really nasty things. But if I was thinking about partial fractions, let's just think about what that means for this piece here. I'm looking for the simplest collection of fractions I could add together, the most basic fractions I could add together that would give me this. And so you think, you've got to have all these denominators appear. So you definitely need an s plus 2, and you need an s minus 3, and you certainly need an s, but you also need to make sure you have an s squared in there too, just to account for all the greatest possible thing that could add up to be this, right? So now if you added these all together, you would get a common denominator, and this would be that common denominator. Yes, ma'am?
Why is it s and s squared?
Because, so like because I'm looking for the ultimate list of possibilities that could add up to be that fraction there, Kitra. So if I don't include this, I'm leaving out the possibility, well, that this was one of the fractions included. So like you would certainly agree that if I added these two together, I would get s squared as the common denominator, right? So I've got it, so like if this was s cubed, I'd have an s squared and an s as well.
Okay, yeah.
Just, yes, does that make sense?
Yeah.
Cool, awesome. Other questions? Luckily, we're not gonna do that today, because I wanted you to be able to do some problems over the break, and that could take a whole damn hour plus to talk about that. Let's leave that up. So, let me get me the awesome calculator out and show you what we're gonna do. And I've got a link for this in, I think the content area of our page. Nathan, my friend, lights please, thank you. Okay, cool. This is the one that I found that seemed the nicest. They all have these ads thrown in your face, so there's no like freebies that come truly free. But this one works really good. So, and it's easy to enter stuff. It's not like web work or something like that. So here I just put in the numerator. It's just 1. Yay. And then down here, and you can even use s. I'm going to enter that denominator. It's s squared times s minus 3 times s plus 2. And then I just hit enter, and I think that's all I need to do. And then I scroll down, and look, it actually does all the work, shows the setup, shows solving for the coefficients. Aren't you glad we're not doing that? Look at that. And look at the decomposition. Good Lord. That's a beast.
So would we not do this on the exam?
That is correct.
Okay.
Yes. You will have to do, like what I would probably do is like give you the expansion or something, and then, I don't know, we'll figure it out. But I would never ask you to do this on the test, unless this was all you had to do on the test, just that.
Here's the answer. Solve
Yeah,
the fraction.
exactly, yeah. We're gonna write that out down here, so I'm gonna have y transform equals, let's see here, good Lord, is that, what is the first, I can't even read.
That's 1/36
Thank you.
over S.
136 over s.
And then negative 1/6 over S
Well,
squared.
it's being brighter.
That's cool, that's great.
And 1/45 over S minus 3.
And
Negative 1/20 over S plus 2.
cool, thanks, thank you. Now I'm gonna do this one and add that in there as well. You can see why it might have been helpful to put them together first, just to like minimize the suffering, but I wanted to just have a different denominator example here. It's an easy tweak. And then enter, and boom. Come on, oh, look, it's typing it in LaTeX, that's awesome. Okay, so,
Yes.
thank you.
That's 2/5 over S minus 3 plus 3/5 over S plus 2. That was
Thank-
nice.
That's nice, that one's nice. That one's hunky-dory. All right, so I'm gonna take this down, because we don't need that anymore. But please use this for the web work that I've got for you, and any other things I ask you to use. I don't know, I'm trying to think, we could maybe even use it for the final. I should know you're part of this, There are some things that I would probably want to combine here. We got some fraction work to do. Let's just get like terms together before we undo this thing. So we've got y equals, first off, you can read some of the parts of the answer off, right? This is just going to be 136 times 1. This is going to be minus 1/6t. I mean, we can actually read off all, let's just write all this shit down. Let's just do it, it'll be so much easier just to get done with it. So 136 minus 1/6t. You'll start to recognize some of these. Hopefully 1 over s squared you're recognizing already. And the 1 over s, those are so common. And then we've got plus 1/45 e to the 3t minus 1/20th e to the negative 2t plus 2/5 e to the 3t, and then that was a minus, or plus 3/5 e to the negative 2t. We're done. Like, that's the answer. It's not the prettiest form of the answer. Prettiest form of the answer is going to be when I actually combine like terms, and I'm going to do it because there are a few places in life that I'm OCD about, as you can observe daily. But let's get these two together. So I'm going to multiply that, so that becomes 18/45, so 19/45 e to the 3t, and then this is 12/20ths minus 1/20th is 11/20ths. E to the negative 2t. We're done. Oh, this should say, sorry, this should say y of t. That is no longer. Ooh, excuse me, because I've undone things at that point. And then this, I don't know what that is. So apart from the partial fractions, this is almost miraculous. I find this I still am amazed by this all. It's really cool. Think about how hard it would have been. First, you'd have to go do your YP, right? You'd say, oh, YP was AT plus B. Find the A and the B. Put those back on. Find the homogeneous solution. Add the YP and the YH. Solve for the initial conditions. That's ugly. That's a lot of work. I think this is a lot less work overall, especially with our computer friend to help us out. That's how it works, friends. Yes, Daniel.
I think I'm okay with the process, but I don't understand what is happening. I'm not seeing what we're doing, why it works. I don't know.
Well, it's almost impossible to understand why it works. I don't understand why it works.
I wasn't asked the exact same question, but I realized there's probably not a good answer for it.
There isn't a really good answer for it, except that we're transforming from a place we're used to, just the calculus world, into this new space via calculus, right? Because it's an integral that got us there. But just miraculously, once we get there, things just work differently and more easily. And so it's just like a case that somehow somebody experimented with this and realized, or Laplace thought, I'm gonna try this, and it worked out. I know that's not super satisfying. I don't know if I can give a satisfying answer.
Okay.
Sorry.
Yeah,
I'll look into it. I'll see if I can find something more satisfying for both of us, but and Chris too, if he needs something. Everybody wants that. Everybody wants understanding. But you're cool with the process. So just accept it as magic.
Yes.
All right, my friends, that's it for now. So you've got a web work that should be opened up. Let's at least start on that. Can someone do a few action shots? Please.
I took some earlier.
Of me?
Yeah.
You did?
Oh, those are the best ones that you don't know.
Oh, wow.
It was a cool picture.
Really? Okay.
Yeah, you can see
I'm
them.
gonna, cool. Can you send them to me?
Yeah. Do you want to see them first?
Yeah, maybe. Yeah.
It's just you writing an equation. That's kind of it. And then there's this.
Oh, that's nice. They're really nice high-res ones. That's cool.
It's live too, so people can use.
Ooh, you could pick any of those too, right? Yeah.
I can email them to you if you want.
I would like that. Thank you.
Is this Laplace Transforms?
Mm-hmm.
It's open for 6 days.
Well, that's not right. So, we'll fix
It
that.
opens when it's due. And you have only 15 seconds.
Smooth open.
Get going. My God.
And it's from the classroom.
I love that.
Oh no, but it
I kind of want just a few more, if possible, though. Just where my face is more visible because I'm really trying to get my face out there and get famous.
Oh god. No, I think I'm branded to you because before I ask questions at the end, I just look at it and I don't look at it. Actually, this is.
Do you think they'll stay high res if we email them? Do they give you an option on quality?
Huh?
Do they give you an option on picture quality when you upload them? Resolution? Yeah, does it destroy the resolution? Maybe
I
not.
don't know.
We'll
I'll
find
find
out.
it if you're just sending one or two.
That's true. That's probably right. this, yeah, today's not the 11th. Nope, it's the 5th. So, and then let's see, when should this be due? How about next Tuesday? Does that sound okay?
Yeah.
It was like a week, right?
Yeah.
Okay. Okay. All right, that should work. That should have done it.
It opens at midnight.
Already. We're kind of there. Get all ready to watch TikTok. The TikTok, as the old folks like to say. Let's see. So yeah, that's not good. What time? Let's just say 1. It opened at 1 p.m. There we go. All right. Tell me how I did. You're good. Woo-hoo! Ow. How many? 13. 13 questions indeed. Lucky 13.
13 is a good number.
It's not bad.
When it says you negate the derivative of, what does that mean?
Put a negative sign in front.
Oh, okay.
These surprise pictures, you don't know when they're coming.
You should watch the problems inside.
It sounds like you're calling us a math class. Like, you know the Uncle Sam pictures? That's what this
Oh,
one
God.
looks
You took that! Oh, shit! That's like...
I need you for
like.
that.
Go look at it.
And I'm trying to look angry, too. Like, because it's like, let's see here. So, just recall. The Laplace Transform, just wait till I turn around, of f of t was defined to be the integral of 0 to infinity of f
Pause
of
when
t
you turn around.
times
Yeah,
e to the negative of
Yeah.
t dt. Does this? Okay, thanks. I hope some of those maybe turned out.
I liked all the pointing around the time. Like, silence just. They're good pictures, though.
Okay, thank
Yeah.
you, ladies. That was a great help. Somebody's got to do that for Cybert. Cybert's supposed to get pictures of himself too. Yeah.
I started writing what you were saying.
Yeah, I don't know that.
No,
Okay, let's take a look.
So,
Of course.
that's
Let me get different glasses. Let me get my close-ups.
Oh, they have ones. Did that make any sense? Yeah.
Yeah, so it shouldn't be y equals. It should be 0 equals.
oh.
So try that and see if that actually helps.
Okay.
Yeah,
I see. Okay, well, there are just a few other points that were in there. I don't
If when you find them, maybe look through them, just let me
Yeah.
know.
Yeah.
We'll get them cleared up.
Okay, I will.
It says,
You're doing good, Grace.
What is negate the derivative? I don't.
make it negative. As, I just asked that like 5 minutes ago, and it was like, you just the negative derivative. So like, don't, you just take the derivative.
So no, let's see, what does it want here?
Transform, blah, blah, blah.
Oh, it just wants, so it's asking you a simpler
I'm
question. You negate the derivative of, so it doesn't want the L there, it just wants the thing, you have to take the derivative of to get that Laplace transform. So remember that a negative t, let me help, which problem is this? Number 1.
We're all on the same page.
We made it real far. Okay, so, my new thing. So they say,
I'm not the only one.
You're not, so the question, everyone is just like, what the fuck? So the question, what, somebody read it to me.
Yeah, I have it right here now.
Thank you. Just
Or,
kidding.
do you want me to read it to you?
Yeah, please.
Since t cosine h at plus 7t cosine at equals t cosine h at.
I have a total.
Yeah.
Well,
plus-
everybody's will be a little bit
plus
different.
7 cosine at.
I don't even understand what the hell that's, why they're writing.
Alright, so since that equation,
Yes.
and then comma, to find the Laplace transform at t cosine at plus 7t cosine at, you negate the derivative of.
Hold on, can you fix that question?
Leave it.
Oh no.
Edit problems.
You say bye-bye.
Well, I think there's gonna be 12 problems. And that one is not as good as I thought it was. Does that sound, yeah.
What does
we're
it
all
even
good with
mean?
that. What's that?
What does that question even mean?
They're asking for the transform of the thing you'd need to take the derivative of to get the t derivative. So, so like to get this t in here, to take the Laplace transform of this, you would have to go negative derivative of the Laplace transform of cosh at. That's what they're asking. But we're not fucking.
Okay, good, I appreciate it.
You're welcome. It helps us all.
Oh, one word error, number one.
Okay, hold on. Yeah, stop clicking stuff.
I got stuck in like the Matrix.
You clicked problem one.
Oh shit! I think I
You
deleted.
just deleted it.
I do. It was number 1, right?
Yeah.
Okay, good. Let me renumber. I want to renumber all these because it's starting at 2
problems 2
now.
through 13, like specific.
Force problems. Okay, let me say. Please don't click. Don't click. You know. Sorry. Stop clicking. Just hold on. Just hold on. You can click in a second.
Oh my gosh.
Okay, save changes. There you go. Click away.
I'm just gonna refine it.
Alright, we're good.
Okay, good. That's the answer to that one, Thomas. Okay. Is the next one like baffling you too? Okay, good. Okay, good. It made sense to me when I read it the first time.
Do they give you like a list of questions you can choose from?
Oh yeah, I got a bank of them that I go through and like think about. Sometimes I'm picking bad problems. They look good. They look better than they actually are. Alright, I'm gonna run to the restroom real quick. Be right back.
Are you doing number 2?
Yeah,
Sorry, one.
number 1,
So you said
it's not
you write an equation or you write this?
I'm writing an equation.
That's what I thought.
We're about to see if that's correct.
Bless you.
It is. No, it was not correct.
What the fuck?
I don't know. Oh, what?
I have a 30 score.
Wait. What the, you're on problem 2. You submitted it in a problem 2, but you looked at problem 1. Oh. You know what I mean? Oh, that's so rude. Oh yeah, it moved me around. Okay, we're gonna try that again. Okay, no, that was correct. It just went into the wrong problem.
Okay.
So yeah, you have to do it again.
absolutely.
Make
Oh,
sure
yeah,
that's
easy.
So then
Yeah.
my other question
But
is
it's like
like,
the
I'm finding
first crosses it, that's the
is
like the
why is figure exclusive to plus 0 for x.
You're thinking of y versus x, this is x versus t. So we're setting the output equal to zero, defining what t times t, the x, x is the output here.
Yeah,
So I think you're twisting it in your head to the classic y.
So does that mean 0 should be set equal
Yes.
to this?
Yes, yes.
That makes more sense. Okay.
Yes,
Yeah,
absolutely.
okay.
And then you probably need to do it like with like a calculator kind of thing
Okay,
or
cool.
something like that.
And then maximum extension. Is
So
that-
you need to convert this, did you convert it into phase amplitude form?
No.
That's what you should do.
Okay.
Then that'll be obvious.
Okay.
What that amplitude would
Okay.
be. Yeah, yeah.
Awesome.
Does
Thank
that make
you.
sense?
Yeah, it does.
Cool.
Thank you.
How did you guys get the first one, like the first part? Because I got the second and computers.
Well, you might have.
You want me to take a look too?
Like the three things on the board kind of us really help because whatever your K is on your E, then it'll help you know what to put for the S plus or the S minus
Okay.
K. If this is like mine, my E is negative 2t.
And then is it sine HAT?
Yes.
Okay.
So then I have S plus t. Originally I was putting in minus, but if you have like a negative K,
I was asking for
plus,
the,
if you have a positive K, you have minus.
what is this?
That makes sense.
So it's
What
S
did you
plus-
substitute s plus 7 into to get that?
S plus 2 minus.
What did you
Negative
substitute
2t.
s plus 7
plus
in to
2.
get this
Okay,
expression?
That makes sense.
Yes, so.
So this
now I
expression
understand. It's
here
what you
is some other
substituted.
expression
For
with
K,
s
yeah,
replaced by s
yeah.
plus 7. So basically, undo it, replace s plus 7 with just s.
But now, not so sure. So it's like what we substitute in.
Well, the whole
it's like
thing,
a
so you want the
capital
whole thing.
F. It's
so-
what we're substituting
order
into
to
that to replace K, believe.
You're thinking way too hard about
Yeah.
this. This expression, what was this before you plugged in s plus 7? So just write this expression down again with just s instead of s plus 7. So negative a over a squared minus s squared. Yes,
So
yes.
that means you're replacing S
Got it,
with
okay,
S
cool.
plus 8.
It's kind of a dumb, that's another dumb one. I would erase that shit if
Even
I
though
had the
it's already
chance. But
done.
it's kind of easy too, so
Just to say that that's
once you
not
actually
the
understand
actual
what
problem, that's just what you
it's
did.
asking.
You're replacing this S
Okay.
with S
So
plus,
it's S plus
and then you solve it, and then.
K value, it's not K.
Sure.
So in
So-
my case, it's 2. Well, it's negative 2, but it says S minus K, and so the sign switches to 2.
I have.
I'm sorry.
And then the second one is just on the sheet. That's what we looked at.
In this case, I don't know if I'm.
You are, and it's so, the question is so fucking dumb that it's, okay, so let me.
Yeah, I'm deleting it.
Which one is that, number 2?
This is
So
number
it's
2
now
now.
number 2.
It's number 3 also?
It's number 2 and 3?
Really? Really?
Yeah, it is.
It's not. for
Are you
me.
How
kidding
many we play?
Oh, it's kind of, they're a little different.
Number 3 is a little more complex, but essentially.
Just a bit. Number 3 is a little more interesting. Number 2 is goofiness. So they're saying, they give you some transform thing. Chris got a really weird one with parameters, but let's say it's like, this equals what function where s is replaced, they don't have, like I would write it.
Oh.
What is the thing that you plugged s plus 7 in for to replace an s? And the answer is that.
That's so ridiculous.
Yeah, it's kind of dumb.
Is that for 2 or 3?
Makes sense.
That's
That's an S.
2. That's 2.
Oh.
3 actually has you do the inverse transform, so that's a little more.
Oh, this is
Substantive.
so funny. Why? Why would they do this?
Yeah, I don't know either. And why would I assign it, Kendra? I think that's what you're asking.
And then,
So when it asks what the inverse Laplace transform is, are you actually solving for the whole
Let
thing?
me look, I gotta see, now I didn't even read past that part. Oh, yeah, so now they're asking you to do the shift. So you're gonna replace s with s minus 8, so it's gonna be e to the negative 18.
Yeah.
Yes, yes. Well, let's see. And then that other one, that looks like a hyperbolic
It's
sign. Yeah.
But if
And it's
you
backwards,
make it
too.
negative, yeah. Because it has a negative out in front, so I just distributed that
Yes.
route.
Perfect, that's good, yeah, yeah.
But
So-
it said no.
So this should be negative e to the negative at times, and then put a hyperbolic sign of a t. Well, let's see. Therefore, the inverse transform. I don't know, that seems right to me. Let me go look at what the answer is. I'm glad we're all together for this. It would suck otherwise.
How did you write your first question?
Very first one?
No, for two.
They get better, I'm sorry.
You basically just redo this, except replace the s plus whatever with s. You just redo this entire equation. Oh, that's why you silly goose.
No.
Did it work?
Mine?
Oh, Chris's, so let's see here, so,
That's fine.
okay.
I don't know, so, cause it looks like that, yeah, but I don't know what n is supposed to be, it's not 6.
Oh, they already have a negative in front,
Because it's an
Kendra.
X. They do?
It's just hard to see it. Look,
Oh,
so just make it positive, that's the.
oh, that's a pain in my booty. Alright, coolio, thank you.
You're
It's
welcome.
not that we're supposed to write it,
Yes, ma'am.
so, like, on this.
No, I'm pretty positive you're right. Cause it would be.
So first, no, so, what is the, how do you factor that out? Right,
I feel
so
like
if you
720
replaced,
has something
the-
to do with it.
so let me see where you got it right here.
Because
So
Because
what-
that's the.
6
Oh
factorial
my
720.
Oh, that's so
I'm pretty sure because
That's so
it's.
hard.
Can
Can I
I
take yours up here?
times
No, take this up, we'll do this for you.
360 times 2, yeah.
You're welcome.
So
Alright.
why is it not 2 6? Maybe it's because, do they want to use a
So-
different variable? X, S, X, S, X? No, I used T. I don't know what the
Vivian
deal
on
is.
this one, here, I'll give you this thing back. So this is
It
number
is something to the 6.
3, right?
I've already used T.
So the
That's
bottom
so weird,
is
though.
gonna be, so F, the thing
Oh,
F,
that's why. You
is
have
gonna
to
have an
do
s squared in the
E's.
bottom. So if I replace s
So
with
it
s
has
minus
these
5, I would
switch
get that.
back to a regular
But what
S,
would
so
I
you
have to
keep
have
it
on
the six.
top? And that would be s plus
And you have to
5.
include the E.
Does that make sense?
So it's like,
It's tricky, it's in
Yeah,
both
we did that in the
places.
last problem.
So now if I take s and replace this
Yeah.
s with s minus 5, I get this expression.
You put whatever
so
you do.
that on the left is when you already moved s into s's.
Correct.
And you put E to
Yes.
E T out in front.
Another way to get this f is to replace every s with s plus 5.
Right.
Yes.
Okay.
Saying it like that helps. Yes, okay.
Yeah, negative.
Why?
Alright, let's talk.
I can, I'll enter.
Okay, the same one we're just working on. Okay,
So
cool.
it's whatever is in here, so it's negative 5.
Okay, good
Oh,
lord.
So silly.
I know.
Opposite of what you
Alright,
substitute
So,
in.
what did you need?
And then it's a T on
So this
that,
is,
E to the
this was
negative
something
X.
before,
Yes.
and then we took that thing and replaced s with s minus 3. What was that thing?
So I think we're a lot of this is that.
Okay. If you replace s with s plus 3, what does that turn into? That's the thing we're looking for,
Oh, so it's just,
over s to the 10th.
This is so silly.
All right, I've heard enough of you.
I'm sorry. I'm getting
I'm
frustrated
just
with
kidding.
myself.
I know, I'm frustrated that I made such shitty problems on here, so.
It's not
They
bad.
get
It's not
better,
bad.
they get better.
They're just a little bit.
So there, now, so it's gonna be the inverse transform of this times e to the negative 3t.
inverse transform of this times e to the negative 3.
Yes. And you, boy, they really socked you with that. That number on top is big, but just use a calculator, cause you're, yeah.
Times I'm sorry, my brain is not working today.
You can e to the negative 3t.
Because k is,
Because we're doing a shift, right? So this thing, here, let me write it up here. It's actually this thing we're doing here, Hans. So I'm gonna replace s with s plus 3. Oh, wait. God, I hate these, I'm so regretting all of this, but not because of you all, because they're so just frustrating. So, you've got, so let's actually just look at this from first principles. Good Lord. Jesus.
yeah.
Yeah. Hans got the lucky ticket. So we're gonna do L inverse of that. So I'm gonna use that law up there, the one that says L inverse of f of s. And what I'm gonna do is replace s with s plus 3 so that this turns into something I recognize, which is just an s to the 10th in the bottom. That I can do, because that'll be like t to the 9th or something. So I'm gonna replace s with s plus 3, and then this turns into s to the, there's actually a couple things we have to do here. Let's just work this one through. I'll work through anybody's for them. Happy to do that. So you just let me know, we'll work it out. So then this is, I would actually pull that horrible constant up front. So how does that, what power of t do we have here then? Sorry, Hans, I'll let you finish writing, I'm sorry. What power of t does that correspond to? Just forget about the top, just look at the rhythm on the bottom.
Would it be 9?
Yeah, exactly. And if it was, what is the Laplace transform of t to the 9th? It's 9 factorial over s to the 10th. So we need a 9 factorial on top, and then we divide by a 9 factorial out front. And then that just becomes a perfect t to the 9th. And I think I'd written some rule up earlier. Let's put it up again. I don't think it's up here, but L inverse of 1 over s to the nth is, let's put n, yeah, let's just use n, whatever, is n minus 1 no, it's not. It's 1 over n minus 1 factorial t to the n minus 1th. That's not a bad law to have around either. It's kind of a twist on the formulas, the way we have it.
So then the
Yes,
answer
yes.
is, well, let's put this up here, t to the 9th times this.
Yes, yes.
Okay,
Let's try it. Let's see. I'm going to be here with you.
moment of truth.
I'm going in with you.
Replacing this with
Cool.
I'm trying to figure out the easiest way to do this without like working.
You forgot a 2, I think. It's 36280. Just 7, yeah, there we go. Yeah, and that should be it. Huzzah! Yes, good work. We can do it together. Anybody else need any problems worked? Okay, Ella. Okay, well, were you, okay, I'll come back. Yes, ma'am.
So I submitted like a lot.
Okay.
And so
Okay, so that looks great. Well, obviously it's green, right?
I'm looking because first I tried this one is doing all analysis.
Replace S with S plus 3. So this is asking, what did you plug S minus 3 into to get that? This is saying, find the F, the thing that you need to plug S minus 3 into to get that expression. And that expression, am I right? So we have S over, it's actually S minus 3 quantity squared, right? Yeah. So what is it I had to plug S plus 3 into to get that? And the answer is, if I had this and replaced, yes, if I took this and replaced every S with S minus 3, I would have that expression back.
Okay.
You see, it's weird, it's really weird. So this is gonna be S plus 3 quantity over S squared.
Okay. And if I would have plugged S plus 3 in for here.
That would
and
work.
simplified, then it would have gotten that.
You would? Yes. Yes, ma'am.
So
There you go.
then I have a little.
Yeah, I'm going, all right.
So what I'm getting, so I have my,
We're doing the same one here? Okay, yeah, yeah.
that way everything is separate because so that's what I have.
Okay, yeah, that looks right.
And so then I put this out here for the little substitution.
Yes, yes. Wait, so let's see. So we are taking,
That 7 should be there.
yes, so e to the 7t. What is it they actually wanted to transform? I guess that thing, that's what we want. Let's just do this from, I gotta like write it out. Like the way that's set up is very confusing, so I understand.
Yeah.
Yes, so we want,
Really, yeah.
and is this right, Kitra? Is this the thing that we want?
Yes.
Okay, so I'm gonna replace S with S plus 7.
Yes.
So that means I'm gonna do that, I'm gonna put e to the 7, e to the 7t out front, and then replace S with S plus 7. So I get that. So then to undo this, I would break this fraction apart. And then it becomes 1 over S plus 7 over S squared. And then
Yeah.
and that makes things a lot better, right? Yeah, yeah. When you have a sum on top, I would usually break it apart if it's just a single thing in the denominator.
Helps, yes.
Yes, that helped. Okay,
Yeah.
awesome. That was kind of useful. It's like the first useful thing in the first 3 problems.
Oops, I did.
Oh, yes, Thomas.
Basically the same.
Okay, you're good now. Awesome. You doing good? Yeah?
Maybe.
No more deep ones. This isn't a deep question, right?
I don't think so.
Okay, good.
It's just, it's the same thing, but, so, Jesus, that's fine.
Okay.
Yeah, I'm not sure what to do.
Oh, okay, so let's write out what we
Oh
want.
yeah, I'm putting the 7s because I'm
What
like.
if I just do it
Side
there?
of
It's
3s.
okay, thanks.
Oh, stop.
Oh, you don't need any, no sorries needed.
B2 1 over S.
Yeah.
Is 1. This little addition becomes a multiply this term. Oh, and so I put the whole
Well, it's gonna be in red.
Or it's just a multiply.
I think that's
Whole thing.
okay. So what we really want, Daniel, is this.
Yep.
That
That's
makes
the
sense
thing we're
because it's
really
outside.
looking for, inevitably.
Here, I have to find the F of
Yeah, well, yeah, so f of t is this thing, that's what we're looking for here, so that's the f of t. So let's work this through. This is gonna be L inverse of S over
So
S plus 2 quantity squared.
So you just pull the constant off in front of.
I wanna get this, turn this into S squared. Yes. So I'm gonna put in E, I'm gonna replace S with S minus 2. I got that. Then I'm gonna break that apart. It's s over s squared minus 2 over s squared.
Okay.
And then each of those is just
Okay, that helps.
cake, yeah. No, that one has to be minus, so let's take a look at that one, number 4. Of course we're on number 4, because every problem here stinks. 1, 2, 3, and 4, all of them. So let me show you what they're up to in number 4, Vivian, because everybody is going to want to see this. May I borrow this? Thank you. Number 4, I'll make up a version of it. So we've got, let's see here, so minus 6s. This is kind of the same problem here. So the first thing we need to do is complete the square in the denominator. That's what that first step's about. So they're asking us to rewrite this as s minus, well, break it apart kind of like you did, so minus 6s, and then pull this plus 18 over here like that. I take half this coefficient, so that's negative 3, and square it and add it on. But I also have to subtract that same thing. So this should turn into 1 over s minus 3 squared plus 9. So you have to do the same thing there. And yours should be a minus because, wait, let me take a look. Yeah, it should be, because you've got s minus 10s.
They want me to put in negative.
Yes, they want s minus 5.
Okay.
Yes, ma'am.
So you take half of that negative 6.
Yeah, and square it, so I took minus 3 squared and added it on. So that makes this part a perfect square, and then compensate Ella by also subtracting that off so that I didn't just change the whole problem.
Okay.
No, wait, Hans, you do have your hand. We'll take a look at it.
Okay, so I'm having trouble, well, I got these two, so I'm having trouble synthesizing like what I'm supposed to do with this.
We just think of the problem is, I want the inverse transform of that.
Okay.
So look at that thing that I've done up there. So check out, yeah, and this one's gonna work out the same. So it's kind of in, yeah, that one up there that I did for Daniel. So yours looks a lot like that, except that you've got s plus 6 in the bottom, and an s on top. So you've got inverse transform of s over s plus 6 quantity squared. That's what this is.
So
Okay.
negative
So let's just work from there. This will be more useful to think of it this way anyway.
S minus 2.
So does that make sense what you've got? You've got that.
Positive 4.
And just write it as, I would just write it as a plus 6. Let's just write L inverse of s over s plus 6 quantity squared. The way they've got this here is,
Yeah, it's weird.
it is weird and it's disturbing. Okay, what you wish you had is just an s squared in the bottom. That's what we're shooting
So
for.
we have to replace s with an s minus 6.
There you go.
Okay.
So you put the e to the negative, yeah.
So e to the negative 6
Yes, e to the negative 6t, yep,
over,
s squared. Yes.
okay.
And then see how that, I broke it apart into 2 fractions? So
Oh,
it was,
because that's easier.
yep, so it's s over s squared minus 6 over s squared.
So that's 1 over s
There you go.
minus 6 over s squared.
Yeah,
-6t.
yeah.
And then I'll just look at the sheet.
And then,
for the
yeah,
rest of
those
it.
are easy. Those are straight up.
Okay. Thank you.
Ella, did you get that?
Yeah.
Okay. Okay, probably.
But this is one.
Yes.
It's an
That's t, that's 5t.
I don't know why I thought I had
Well, you pull the 5 out in front, definitely. And the t doesn't need like a lot of adjustment. So like a good thing to just keep in mind is that 1 over s is 1, you got that. 1 over s squared is t. then 1/s cubed would be some multiple, it's like, that would be like a 1/2 t.
So it's like a
It's pretty far. Yes.
I don't know why I was trying to like answer
That's okay, because this is brand new, right? So you're doing great. How is it going?
Just feel like it should.
Let's see, yes,
I
this
was
is,
just following along before we.
okay, so,
Same
this,
logic.
okay, yeah, it
Unless I
does.
just did something.
No, so this one, the only thing you need, this came from negative a over a squared minus s squared with s replaced by s minus 9. So the thing they're looking over here for is that negative a, so let's type this together so you can see what I mean. And definitely just get it knocked out. So negative a over, and then in quantity, a squared minus s squared. See you, Daniel.
See ya.
And paren, close. Yeah, there's that right paren should be on the outside there.
Yeah.
There you go. Beautiful, try that.
Oh,
Do you see,
I
do you
did
see
see the
now,
page
do you
in
kind of
there.
see what they're doing now?
yeah, yeah.
Okay.
Although, I'm confused because in the s minus 7, it was just 3 over s plus 7. So why is it in this case it's negative a over a squared minus s?
I don't know, that was a different problem. I don't know what the problem was, so I'm not sure which one we're thinking about. I see you, Grace, I'll get you.
I was just throwing off the, I think it was probably yeah.
Oh, yeah.
S plus 7 is 0 minus 7.
Yeah, so that one's got, I mean, that one had a 3 on top, right? This is
so-
just, you just got a different setup here.
Okay.
Yeah.
Okay.
Tomorrow
Yeah?
morning
Yeah.
class.
Yeah, okay, cool, all right.
But I'll see you tonight. Oh no,
You're
you're not
welcome.
coming tonight. Okay.
I'm coming.
See ya.